All right, we're going to start with number 2 on the projectile motion worksheet. But this first part, I want to just talk you through some things to think about for how to approach a problem like this. And then I'm going to make a separate video for how to actually finish solving it. So what's different about this problem is you are not going to be able to solve for certain things at the beginning. And instead, you're going to have to create an expression, kind of like an equation, but only with one side, where you are going to have something equal to something else where you still have variables in it. And this is probably the first time you're going to do something quite like this. So if it's hard, that's okay. And that's expected. So just know that going in, this is tricky. This is probably something new that you have not done before. So what we're going to start with is we're going to start by just filling in the things that we know. So we have a starting velocity of v naught. We don't actually know what the velocity is. And she's going to jump approximately 3.5 meters. So this 3.5 meters is how far she goes. So I'm going to put that in for my x, and I'm going to say she started at a position of 0. Now, in terms of her height, she's starting at a starting height of 0 and ending at a height of 0. So for y naught and y, those can be 0. I don't know how fast she jumped in the x or y direction, but I do know that it was at an angle of 40 degrees. And that is important because I can write then an expression for what these are. So I don't know what v naught y was, but if I knew what my velocity was on the hypotenuse, or my overall velocity, and because I know the angle, I could be like, oh, okay, well, this is the opposite side of the triangle because my 90 degrees is here. And so I can use sine. So sine of my angle of 40 degrees is equal to opposite over hypotenuse. Well, my opposite is v naught y, and my hypotenuse is my overall starting velocity, or v naught. So what I can do is I can multiply both sides by v naught, and then I get v naught times sine of 40. So then all of this is going to become v naught y. And I can do the same thing for the x direction. But the x direction, it's adjacent. So I need to use cosine. So now I have an expression for v naught x. So this is my starting velocity in the x direction, and I have a starting velocity in the y direction. Okay, so I have an expression for v naught y and v naught x, and so I'm going to put those over here. So my v naught x is v naught times cosine of 40, and my v naught y is v naught times sine of 40. So I don't know what they are, and I'm going to be able to find them out, but I don't know them yet. But I do know that the acceleration in the x direction is going to be 0 because nothing is pushing her sideways. And her acceleration in the y direction is negative 9.81 because the gravitational force is pulling her down. What this means is that whatever we get for this starting velocity in the x direction, it'll be the same for my final velocity in the x direction. So now what we're going to do is I'm going to look at this and I'm going to notice that I have more information that is going to be useful in the x direction. So I'm going to write out the equation for the x direction. And in the x direction, the final position is 3.5. Starting position is 0. I don't know what v naught x is, but I can take all of this and put it in for v naught x. And my acceleration in the x direction is 0. So 1/2 times 0 times squared, this whole thing is going to become 0. And so I end up with 3.5 is equal to v naught times cosine of 40 times time. So now I have an equation, but I have two unknowns. So now what I'm going to do is I'm going to do the y direction. So here's the y direction equation. And so what I'm going to need to do now is plug in the things I know for this. All right, well, starting and ending height for the y direction is 0. V naught y, I'm going to use this. Time is still t. Acceleration in the y direction is negative 9.81. All right, again, I have 2 equations and 2 unknowns. So what I can do now is I can take and solve for one and put it into the other. Well, if I solve this first equation for V naught, and I get V naught equals some stuff, that's easier than if I do time is equal to some stuff, because when I go to plug it into this, the t would get squared and I would have to put it in here. And that's going to get gross. So instead, I'm going to want to solve for V naught because there's only one V naught. And then I'm going to put the V naught here. All right, so try that. And then what you'll do once you do that is you'll get time. And once you have time, you can put it back in to this equation and solve for V naught. And if you have that, then you're good to go. Then you'll be able to solve for the x and y, and you'll have the overall velocity at the beginning. If you've got questions, let me know. Otherwise, I'll do this again for the whole problem.